Okay, so I hope that you are doing very well now. I just want to finish this lesson today, and then tomorrow I will talk about the complex numbers. So that would be the last part of this chapter. And this week, this chapter will be finalized. Next week, probably you will get some time to practice. We need to find the time for having the test. Okay, sooner or later for this chapter and go to the next chapter. Next chapter is much easier. It's very easy. You just need to learn how to solve a system of equations, which is a very simple lesson. Okay. Here, by the way, if you remember, I proved something for you. If A is positive, there is a maximum and minimum, and then if A is negative, I thought that this is above your level, but this is actually one of the level 3 problems in the book. Okay, so finding the turning point, the extreme point of a parabola in general, I saw it in the book to be a level 3 problem. Okay. So more or less everything is finished today, but I just want to give you some examples and then we are done. So most of this session, you will probably find time to practice on your own. And if you have any questions, you can ask me. Okay, so what we learned so far about these polynomials, if I have y equals to ax squared plus bx plus c, and of course, a shouldn't be equal to 0, otherwise this is not a quadratic polynomial in the first place. So we learned that if a is positive, then we have a maximum. Yes, and that's, sorry, minimum. And that's minimum. And then maximum. So here, this does not exist. And this, if you remember, we calculated that time. I don't want you to memorize that, but we learned that the minimum value is equal to minus delta divided by 4a. Of course, delta is also famous expression. It's b squared minus 4ac. So we learned that this is the case. And if you remember, the turning point was actually minus b over 2a and minus delta divided by 4a. So that is the turning point. Okay. And of course, in the case that a is positive, this turning point is the minimum. And if the case where a is negative, let me write this here. So if a is negative, what is changing? What you need to write? Minimum of y does not exist. Yes, and the maximum of y is equal to that expression, minus delta over 4a. And then the turning point is again the same. But of course, here the turning point would be a minimum point. Here the turning point would be a maximum point. So we also learned about the graph of these functions. If a is positive, we have a parabola which opens upward. And then if we have a negative, we have a parabola that opens downward. Yes. And then what we learned about the symmetry line. Yes. For the symmetry line is the line which is perpendicular to the x-axis. So if this is my x-axis, okay, and that is exactly a vertical line that passes through the turning point. Either in this case or in that case, it doesn't matter at all. So it means that in both cases, this is the formula. And of course, I don't want you to memorize that because as I told you, these formulas are not in the formula sheet. So when you want to catch them, you want to find them, you have to know how to use the completing a square method to find those values. And I have solved a lot of examples before, so let us not repeat them. So it's more or less the summary of what we have done for the parabolas. And now we want to give some more mathematical and practical applications. Okay. So let me give you an example. First of all, this is a level 3 problem in the book, so let me solve it. I don't know which problem is that, but of course it is very simple. Example, you are not allowed to use these formulas for this test at least. Okay, I want to test your understanding about if you can find them in the first place. Okay, and these are, as I told you, they are not in the formula sheet. So you need to understand how to complete the square out of it, and using that complete the squared expression inside that, you need to be able to answer these questions. So example, this is one of the examples in the book. So if I more or less like this, show that the minimum of the function of f of x equals to x squared plus px plus q is equal to minus p squared divided by 4 plus q. Yes? So I think it's better now that you are here, you tell me what to do. This is a level 3 problem in the book. It's very, very simple, by the way. Yes? So how should I do that? First, you need to understand the question. First of all, tell me, am I allowed to ask about the minimum for this function?
Yes.
Yes, why?
Positive function.
Because x squared, the coefficient of x squared is positive. Why? Because it is 1. Yes? So, and then we know that if this coefficient is positive, max doesn't exist, but minimum exists. Yes? And then we need to be able to find that. Of course, I told you, if you want to use these formulas, this is very easy, but let us not to use that, and let us do this from scratch again. So I want to find the minimum. Tell me what to do. So I would write it first, y equals to x squared plus px. Actually, this is the very simple one, because the hard ones, the ones that we had a number here, do you remember? We had to divide, but this is already done, so we don't need to do anything at all. So what should I do? Yes?
Divide px with 2.
What?
Px.
Px to power 2?
Divide by 2 and to power of 2.
Yes, so you mean that I need to find the term that I have to add to make it a complete square. And then you go to scratch paper, you divide this middle term by 2 and then square it, yes? So which is p squared divided by 4, yes? So I add to p squared over 4 to this expression. So this becomes x squared plus px, and then p squared 4. And of course, if I just write plus q, this is not correct because I just put this there, which was not present in the beginning. When I add it, I have to do something to compensate for that, to get rid of that. So what I should do, I should negative it. And then as simple as that, you see this is appearing. Yes? And then what happens? This becomes x plus p over 2 to power 2. Because these 3 terms can be collected into this, and then I have minus p squared divided by 4 plus q, yes? So, I don't know, if they consider this proof as a level 3 problem, this shouldn't be considered a level 3 problem, because it was finished, it's finished here actually. Can you see that? I have a number here, I don't know what is that, but I know something about this. Because of this even power, I know that this is what? Non-negative. Yes? I have a number here. This is my number. I am adding something non-negative on top of that. So what happens? This means that this expression is greater than or equal to what? What can I write? Yes? What should I write there?
The exact same expression.
Minus p squared, exactly, divided by 4 plus q. So it means that I was able to show that this y that you gave to me is equal to this, but in this way, I was able to understand immediately that this expression is greater than or equal to that expression. So this means that this y is this or greater than that. So it means that the minimum value for y minimum or minimum of y is equal to minus p squared 4 plus q. Is that understandable? Yeah, so very simple. Let me ask you some questions. So what is the equation of the line of symmetry for this function? The equation of the line. So assume that I give you this in the test. Instead of asking you find the minimum, I ask you find an equation for the line of symmetry. Do you remember what was the rule? You just follow exactly the same thing. What happens then? So let me ask you, so when this minimum is achieved, do you remember? So there are three questions. They can ask you about the y value, they can ask you about the x value, and they can ask you about the symmetry line, yes? If they ask you about the y value, they are asking you about the minimum value, or just simply say minimum. And they sometimes ask you when this minimum is achieved, or when this minimum is occurred. There is only one simple rule. Go back to your calculation, find your complete square, and ask yourself when this becomes 0. Yes? And what is that?
When x is minus
P over 2. Yes? So for minus P over 2, you give two answers. If I ask you when this minimum is achieved, the answer is minus P over 2. If I ask you what is an equation for the symmetry line, you have to write x equal to minus P over 2. If you just simply write minus P over 2 for an equation, this is meaningless. When I say an equation, it means that an expression including an equality sign. So this is the equation, an equation for the symmetry line. So these are not included in the problem. This problem is finished here, but let me just add these things. So if I ask you about an equation for the symmetry line, this is one answer that you can say. If I ask you when the minimum is achieved, so you should write that, okay? Minimum is achieved, is attained or achieved achieved when x is equal to minus P over 2. So there is a slightly difference between this statement and that statement. Okay, you need to understand. Okay, so this is one problem in the book. And then there is another problem. Before going to that problem, let me ask you two different questions, okay? We want to use this idea of minimizing and maximizing to answer some other problems, okay? But as I told you that maximizing and minimizing would be an important topic for the Math 3C and Math 4 lessons, okay? So let me write this as an example. What is the maximum, what is the maximum of the product of two numbers whose sum is equal to 5? When this maximum is achieved? When is this maximum? So is the question clear? How many numbers are there so that the sum is equal to 5?
Two.
How many numbers?
Infinitely.
Infinitely many.
Okay.
Yes, because 1 and 4 is one pair. 2 and 3 is another pair. I don't know, even very strange numbers. For example, 3 over 5 plus 2 over 5. This is also 5. Sorry, this is not 5.
This is one.
Yeah, this is 1. So let me write, for example, 20. Yeah, this is not a good example. Yeah, let me write, for example, 3 minus the square root of 2. And the other one is, I want to make another one so that the sum is 5. 2 plus square root of 2. Yes? If I add these two numbers, the square root of 2's are gone, and then 3 plus 2 are 5. So I want to say that there are infinitely many possibilities for having two numbers whose sum is equal to 5. Okay? So let me make it clear. So assume that I have two numbers, x and y. I am saying that the sum is equal to 5. So I have infinitely many. Assume that I have the bag, this famous bag is, and then I put any pair of numbers so that they satisfy this condition. For example, one of them is x equal to 1, y is equal to 4. And then here, I will have another bag. I would put the product in this bag. Yes. So here, if it is 1 and 4, so what this will give me what? 4. If I multiply. And then let me choose another pair. 2, x equal to 2, y equal to 3. And then what is the product this time? Even though the sum is still 5, but the product is changing. So the product is what this time? 6. Yes? And I ask you, for example, these numbers, little strange numbers we have. 2 minus the square root of 3 and y is equal to 3 plus the square root of 3. Okay, by the way, let us do some practice. Let us multiply these two numbers. X times y, because it is not that evident what should I write in front immediately. So what I have to do, I have to write this and multiply it by 3 plus the square root of 3. So what's the answer? I have to multiply like polynomials. 2 times 3 is 6. 2 times square root of 3 is 2 square root of 3. This times that is minus 3 square root of 3. And this times that is minus the square root of 3 multiplied together is square root of 9, which is 3, yes? But this can be simplified. 6 and 3, negative, it becomes positive 3. 2 square root of 3 minus 3 square root of 3 is just simply minus square root of 3. So it was complicated, more complicated, but we were able to calculate that. So the product is this one. Okay, now you know that I have infinitely many choices here. By the way, this is not the only one. I can go to 10. Yes, x10, what is y then?
Minus 5.
Minus 5, exactly, because the sum is still 5. But now let us multiply. What happens? The product becomes negative 50. So you have infinitely many possibilities here. As it is not possible to list all of them because it's infinite, but you can imagine it. Assume that you have all your pairs and then you start multiplying them. You get a bunch of numbers here. What is the question? The question is that what is the maximum value in this list? And then when this is achieved, for which values of x and y, I will get that particular number. Is the question clear? So I want to find the maximum that I will get at the end in this list. Be careful. It's not possible to do it case by case. The reason is that there are infinitely many options. So yeah, we have to use mathematics somehow to answer this question. So this is one of the practical, of course, this is again application in mathematics itself. Okay, but we come to an example. It's also in the book. It's a very nice one. What is this one now? Okay. So how do you think I can solve this problem? Any ideas? Yeah, actually, you really know everything, except you need to make a model of this problem And then you know that the lesson is related to quadratic polynomials. So there should be a relation between this problem and what you have learned so far for quadratic polynomials. Yes? Okay, so let me ask you what I am supposed to maximize in this case. What is that? What do I want to maximize in this problem? Again, I'm asking the same problem. What should I maximize here? Yes?
The product.
The product. So but the good name for a product, let us call it P. Yes? So my product, I know that I have two numbers. I don't know about anything about them except that I know that the sum is equal to 5. And then my goal is to maximize the product of these two numbers. So my goal, let me call it P. P is x equal to x times y. I myself bring it into the problem. That's a good name because that's a product, so let me call it P. I want to maximize P. Yes? Do you see any relation? This is not a quadratic polynomial yet because I have two variables here. How can I get rid of one of the variables?
For the same variable.
What, pardon?
You mean, okay.
I want to write it, for example, because usually which variable we are familiar with is x. So let me get rid of y in favor of x. What should I
solve
do?
the equation for y.
Exactly. So I will find y from here, 5 minus x, and then I put it here. Then do you agree that the same expression, the x product, is equal to x times 5 minus x? Yes? Here, if I ask you, in how many variables does P depend, you would say x and y. But now in this new form, if I ask you the same question, you will answer only one variable, and that is x. When it depends only on one variable, instead of writing simply as P, if you don't mind, let me write it as P of x. So it means that this is a product, but the value of this product depends on the value that I choose for x according to this relation. Yes? Now, do you see any connection with the concept of parabolas and everything that we have learned so far? Why? Because this is a quadratic polynomial, yes? If I multiply it, what happens? It becomes 5x minus x squared. Yes? And usually in standard polynomials, we write the quadratic term first. So I'm just writing it. It is not necessary, but I want to write it in a way that you can immediately compare it with the standard quadratic polynomial. So this is it. And then you can totally forget about the problem. Your goal is to maximize P of x. Is that clear? We are supposed to maximize P of x. Because P of x is the same product, I want to find it maximum. By the way, is it a good question? Yes, because there is a negative sign, so you know that there should be a maximum for that. Yes? For example, in this question, I couldn't ask you what is the minimum. And I will come back to it to see that it is clear, even without calculation, that I couldn't ask you about the minimum value. It's not hard to see that there is no minimum value. Okay, think about that. Can you, before calculation, you understand yourself? If I ask you the same question, there is no minimum in my list. Okay, I will come back to it. Okay, now let us answer this question. What should I do? What should I do here? So instead of P of x, let me just simply write P, and then I have a negative sign here. Do you remember what we are supposed to do? First of all, we need to get rid of this negative sign. So I have to divide everything by minus 1. If I divide this, it becomes minus P. And then on the right-hand side, I will have x squared minus 5x. Yes? I'm just following. So problem was new up to this point. The rest of it is the previous lesson. I want to find the maximum of a quadratic polynomial. I know what to do, but this is one of those cases that I have a number except 1, so I have to get rid of that one first, so it becomes minus b. And then do you remember what I'm supposed to do? On the right-hand side, I need to add something, so to make it completely squared, but you already know what to do, yes? What is the number that I have to add?
Do you mean negative 5x divided by 2?
No, only negative 5 divided by 2, not x.
Okay.
5 divided by 2 is 5 over 2. Squared is how much? 25 over 4. And then I have to write minus 25 over 4 to compensate for that. And then these three become a complete square. So this becomes x minus 5 over 2 squared. And then I have 25 divided by 4. Agree? But what can I write in front of it? Do you remember? If I have a non-negative value added to this, it is definitely greater than or equal to minus 25 over 4. But this is the value for minus p. I am looking for the value for p itself. So what is the trick? I have to get rid of this minus sign, but I multiplied both sides by a negative sign. But remember, when you multiply by a negative sign, you need to flip the sign, yes? So this becomes p is less than or equal, this becomes 25 over 4. Now, if I ask you what is the maximum of p, what is your answer? What is the maximum?
25 over 4?
4, yes. 25 over 4, which was not easy to guess at all. So it means that if you, in principle, it's not possible. If you write all your numbers in your list, you will get strange numbers as well as nice numbers. But the maximum value is 25 over 4. Okay, so the maximum value that you get on this bag is that one. But another question, when this maximum is achieved? Now answer. When this maximum is achieved? So this is the answer to this part of the problem. When this maximum is achieved? Yes?
When x is equal to 5 over 2.
Exactly. So it means x should be equal to 5 over 2. But when in this problem, I need to answer two variables, x and y. X is 5 over 2. So what happens to y? The sum is supposed to be 5. When x is equal to 5 over 2, y has to be equal? Y has to be equal? Sorry, what? So x is equal to 5 over 2. What is y then?
Y is
5 over 2 again. Yes? Because x plus y is supposed to be 5. One of them is 2.5. The other one has to be 2.5. Yes? So x equals to this and y equal to this. It's very interesting. So if you want to maximize, if the sum of the variables is a constant, if you want to maximize the product, you have to keep them. You have to choose both of them equal. Yes. So in principle, if you go in this list, when you calculate, it was not clear from the beginning. If I choose x equal to 5 over 2, y equal to 5 over 2, this is also one option. Definitely, it will give rise to 25 over 4. But this calculation shows that don't waste your time. You will not find something bigger than this in this list. Is that understandable? Yes? Okay. So that is it. So you see, it was a word problem. There was any notion of parabolas somewhere. But then you need to understand how to make a model out of it and then use your knowledge regarding the quadratic polynomial to answer the question. Is that clear? But please, can you think about this? Why, before any calculations, of course, when I did this calculation, I got a quadratic polynomial with a negative sign for quadratic polynomial. At this stage, I understand that there should be a maximum, no minimum. But before doing that calculation, assume that I ask you what is the minimum of the product. Before doing very big calculations, you should be able to tell me that, okay, Bob, you have written something wrong. There is no minimum. Can you reason for that? What is your argument that there shouldn't be any minimum?
Since
It doesn't need calculations. You need to be able to convince yourself there is no minimum for the product.
Since x squared is negative.
No, here after calculation, but before calculations, yes.
No, I was saying the same thing as
No, because after calculation, yes. After calculation, because of what we have learned in the past 3 sessions, we know. But assume that you don't know anything about quadratic polynomials at all. You haven't learned anything about quadratic polynomials, but still you can understand the question. But now I want you to understand that there is no minimum for this. Why?
Because infinitely downward.
So you need to keep motivate me. Why do you believe that it will go down and down?
You can always choose a larger negative x.
Exactly. That is the idea. Yeah, that's correct.
Rather, a larger x.
Yeah, exactly. So what we are saying is that, for example, let me choose x to be, for example, 6. Then what can I choose for y? I have to choose minus 1. Okay? What is the product? The product is negative because one of them is positive, the other one is negative. Now let me increase x to 7. What happens?
-2.
It becomes -2, and the product becomes -14, goes lower. Okay? And I hope that you immediately understand I can make x a very huge positive number. To compensate for this to come back to 5, I have to choose y to be a huge negative number. But one of them positive, one of them is negative. When I multiply them, it becomes a huge negative number. But that huge negative number is not the end of the story, because still I can increase the value of x and I can go even lower. Yes? So it is clear that there is no minimum, even if you don't know anything about quadratic polynomials. These kinds of arguments, if you want to learn mathematics in a good way, are actually crucial. Let me give you another question, okay? So let us see what you want to do with this. Let me clean this. What is the minimum What is the minimum of, let me write it simply, of x squared plus y squared if x plus y is equal to 6? When this minimum is achieved?
When is this minimum achieved?
When?
Yes. Get some grammar, please.
Yes. Okay, so more or less, I don't want you to write this down, but this is the way I think to make the problem simple. I want to understand what's the problem, so yeah, just I want to give you a little bit of time, and then we can come back and solve it together. Is the question clear? Again, I have infinitely many choices for two numbers whose sum is equal to 6. Assume that you have all of them in your bag, and then you take x and y and put them in that formula. You add these together, these squares, and then you get a new number. So, and then put that number in a new bag. My point is that what is the minimum in that bag? Let me test your understanding. If I just ask you what is the minimum without any constraints, you see, this is a constraint that I am putting on the choices of x and y. When I put this, you cannot choose x equal to 1, y equal to 2, because you're breaking this constraint, you're breaking this rule, yes? Assume that I don't give you this constraint, this rule, and I just ask you about this. It's a matter of seconds, you can immediately answer. What's the minimum of x squared plus y squared? Seconds are finishing. No, it's a matter of minutes now. This is, by the way, one part of the lesson. How, by the way, how did you understand that this is greater than or equal to minus 25 over 4? How did you understand that?
Because x minus 5 over 2 can
Is
be
not exactly.
Yeah.
But that's the same idea. So what? So this is why I want you to learn. Mathematics is not just learning this one. If you understand the core, you can use the same idea there. You told me that x minus 5 over 2 to power 2 is non-negative. So if I ask you what is the minimum of this part only, what's the answer? 0. Okay? So here, if I ask you what is the minimum of x squared,
0.
what's the minimum of y squared?
0.
So what's the minimum of the sum?
0.
So it's a matter of seconds, yes? So, but you need to understand what you're doing, okay? But why this 0 is not the answer to this question yet? Because when this minimum is, when 0 is achieved, when 0 is achieved, when, tell me, when 0 is achieved, when this expression becomes 0? Yes?
When it's
When
0.
both are equal.
Equal to 0. Yes, but if x and y are both equal to 0, what is the sum? The sum is also 0, not 6.
Yeah.
So this is why, if I do not have this constraint, this problem is actually a very simple problem, just 0. But the reason, this is also very interesting. You see that if I say this is 0, I need to know, is this minimum achievable or not? Under this condition, no, because if I want to make this equal to 0, I have to choose x and y both equal to 0. But if both of them are equal to 0, the sum cannot be equal to 6. So it means that among all those pairs whose sum is equal to 6, I want to choose a pair so that this is a minimum. You understand what's going on? Okay, now we have to calculate. This is not something that I can calculate on top of my head, okay? Yes? Yes? Okay, tell me what to do. Yes?
So what I did was I did the same thing. So x squared plus y squared is equal to p, and then I wrote y as 6 minus
Exactly,
x.
exactly. Why? Because I would say that in these maximizing, minimizing functions, by reading the text, you need to find the target function. What is my target function? My target is to minimize this quantity. Okay? So let me give it a name. So Rocco decided to give it P. Let me just write P, for example. So we say that P is equal to x squared plus y squared. I will call it the target function. What do I mean by that? Target. So might be this is not very universally adopted. Okay, the target function. So what is the meaning by target? It means that my goal is to minimize or maximize this. In this problem, I want to minimize this quantity. And then immediately you see one problem here. The problem is that I have two variables. Yes? So far, we have learned only working with one single variable. So it motivates me to get rid of one of these variables in favor of the other one. And usually, we are used to work with x, so let us get rid of y. Of course, it doesn't matter at all which you're getting rid of, okay? So here, I would say that x plus y is equal to 6. I want to eliminate y in favor of x. It's very simple. So I would say that y is equal to 6 minus x. So what is Rocco actually mentioned is this one. And then, of course, you immediately see that I can put it back here. So p is equal to x squared plus 6 minus x to the power of 2. Only this part is today's new lesson. The next part is to use my knowledge about quadratic polynomials. Why this is useful? Because I was lucky. My model turns out to be a quadratic model. It might happen that I give you x to the power of 3 plus y to the power of 3. Okay? And then what will happen, you will get a cubic model, which you don't know how to solve at this stage unless you know the notion of derivative. So this is why the number of problems that I present for you here at this level is very limited, because the model has to be a quadratic model at the end. Otherwise, you cannot solve that. But you immediately know that you have to do something for it. Because even though it has a square term, but it is not still in a standard form. A standard form, it means that I have to expand this, yes? So what happens, it becomes x squared, but you already know the complete squaring pattern. The first 1 to the 2 is 36. 2 times the first one times the second one, minus 12x, and 12x, and then finally x squared. So let me simplify everything. X squared plus x squared is 2x squared. And then I have minus 12x plus 36. This is the model that I was able to get after doing those calculations. As soon as you have your model, you don't need to think about the problem at all. You need to remind yourself about the knowledge you have about quadratic polynomials. So you can totally forget about the problem momentarily, yes? Okay, now is it clear for you that there is a minimum or not?
Yes.
Yes, why?
Because the coefficient of x to the power 2 is positive.
Exactly, thank you. So because this is positive. And that is a parabola, yes? So what should I do? This is one of those a little bit lengthy problems. So what is the first thing that I have to do? You remember? Let us repeat this. I have to get rid of this 2. So I divide by 2. Both sides. So it becomes p over 2. That's very good because all of them are even, so I can get rid of all of them. So it becomes 6x plus 18. Is this a complete square? No, because this is the wrong number. So what is the correct number I need? What is the correct number? What should I have? 9. Of course, I can write minus 9 plus 18, but instead of that, I can write 9 plus 9. Do you agree? It doesn't matter how you do it. But then these 3 becomes what? P over 2 is x minus 3 to power 2 plus a 9 at the end. And now, if I ask you what is the minimum of this expression, what do you say? It is always greater than or equal to which number? 9. Why? Because this part is always non-negative. And then P over 2 is greater than or equal to 9. But I want to talk about P. So it means that I have to multiply by 2. It becomes P greater than or equal to 18. Yes? So what is the answer? What is the minimum of x squared plus y squared? X squared plus y squared is P. So the minimum of P is 18. So this is 18. This is the answer. And it was not clear from the beginning why the minimum value that I can get is 18. But when that minimum is achieved, this means that tell me the x value and the y value. So can you tell me the x value? 3. Exactly, 3. So the x value should be 3. And then what is the y value?
9?
No. The sum is supposed to be 6. Yes, the sum of these two numbers is supposed to be 6.
3.
When one of them is 3, the other one is 3. So it is very interesting. Again, they have to be equal. So if you want to minimize this, you have to choose both of them equal to the same number. 3 and 3. So there are 2 questions. What is the minimum value achievable? Is 18 when it is achieved, when x and y are both chosen to be 3. Yes? Is that clear? Yeah. So that's one part. This is the application of this idea in mathematics itself. But for example, I saw one problem in the book. I don't know exact translation, but I know what's going on here. So this is actually a very important thing for making a function maximum or minimum. Application in other parts of science or in the everyday life, yes? So, and that is, by the way, it's possible. So this question is OSA is actually, I think, if I remember the name of the girl wanted to do this was OSA. So assume that you want, this is the wall of your property or whatever. You want to make a small garden, okay? And then you have only 16 meters of fence. You want to make a fence around that, and then make the garden, okay? And assume that this is very long. For example, this is 50 meters. So you don't have any problem with that. Then, if you want to, usually you have only, this is important, you have only 16 meters of fence. And this is wall. You want to make a garden like this by making a fence around that. You don't need to have a fence here, but you need to have fence on these three sides. Okay? And you want to make your garden here. What do you prefer? You don't have enough, you don't have extra money for buying another piece of fence, so you have only 16 meters of fence. Usually, if you want to make a garden, what do you prefer? Do you prefer to have a big one or a smaller one? Because if you want to have a smaller one, you can just have a wall, yes, and put it there, it's finished. But if you want to make it bigger, so what you can do, it means that I need to optimize something. I don't have more than this at my disposal, but I want to make the area maximum. And that's a very nice problem, by the way. Okay, so I want to see that because, of course, if beauty is not that important for you that much, because might be you can make a garden like that, then you need to put flowers in a row, of course, it might be possible. Okay, but then you can make it a little wider, a little bit shorter but wider. Okay, but assume that the beauty is not that important. What is important for you is just you want to have the maximum possible area for your garden. That's a problem. This is a nice problem. We want to solve it. So I have only 16 meters of fence. I want to do this fence in a way so that finally the area that is covered by that fence is maximized. Do you agree? This is a nice problem, and this is a practical problem, by the way. Let us solve this problem. Might be it is not beautiful. If that's not beautiful, you can get rid of it. I said that, okay, maximizing means to do this, but forget about that because I also care about beauty. Okay, but at least you need to know when the area is maximized by calculation, not by rough guess. Yes.
Okay, so when you build the fence, does it have like 3 or 4 walls?
No, 3. So
3 walls.
So okay. Because this is a wall, with, for example, this wall is tall, you don't need to put fence there, only 3 walls.
Yeah,
so it means that these 3 should add to 16 meters, because I don't have much more than that. Okay? So this is a nice practical problem. Yes? This is one good application, real life application for what we learned here. Okay, so again, you need to make a model out of it. Let me tell you how to think. Again, think about your target function. What do you call the target function here in this problem?
Sum.
No, the target function. What do you want to maximize? Area. That is your. If you don't understand this, then it would be a problem. Okay. So what is the target function? The target function is the area. So you want to maximize the area. So let us call it A for a good reason. I want to maximize this area. You cannot maximize it unless you have a function. If you just write A and say that I want to maximize it, it will not be maximized automatically. You need to do something for it, okay? So what does it mean? It means that you need to write a formula in front of it. But you don't have anything here, so you don't get confused. You just draw one naive picture. You sketch a graph for yourself just to understand the problem. You don't need to be very precise. So what can I write in front of the formula? This is my rectangle. If I want to find the area of the rectangle, I need 2 variables. Yes? I need to know the width and I need to know the length. Yes? So for example, give them names. Let us call this X. Let us call this Y. Yes? And then the area immediately becomes clear. This is X times Y. Understandable? And then you know something between X and Y. How much fence do I have? 16 meters. Okay, so it means that how many Y's are involved in this picture? 2 Y's. So it means that Y plus X plus Y is equal to 16 meters. This is my constraint now. So what can I do? I can immediately see that 2y plus x is equal to 16. Okay. Now what I do, I need to get rid of one of these variables in favor of the other one. Which one do you prefer?
Why?
Okay, if I would say x here,
Why?
but if yes, y is better because you are you are used to use letter x for your variable. But x is just a traditional name. It can be any letters here, yes? So, but if you want to eliminate y, the downside of it is that you have to divide by 2 and work with fractions. So it means that you need to write 2y equals to 16 minus x. And then I divide this 8 minus 1 over 2x. Yes? By the way, do you agree that these are just names? If I realize that this is going to happen, I could name this x and this y from the beginning. And then when you say that let us eliminate y, I will accept it with you and will go on. Because the other one, because the role of x and y will be interchanged. So this is why I want you to understand. These are just dummy variables, yes? I'm just using them for just naming them. Okay, there is nothing very important to them. Okay, so this is why if you want to work with this, that's okay. You can work with this. But then you have to work with fractions until the end of the problem. Okay, it will work. And I really recommend you go home and do it with fractions because it will increase your skills. But because of I don't want to work with fractions, and because it is possible to avoid that, I would eliminate x this time. Yes? So it becomes 16 minus 2y. You see, there is no division by 2. And then I will put it back here. Then what happens? It becomes 16 minus 2y multiplied by another y. And then, of course, this becomes my a. It's it. So finished because it becomes 16y minus 2y squared. This is my a. And then can you tell me how should I write it down so that it looks standard? Because now the first degree term is coming first and then the quadratic term is following it. So what can I do now? Exactly, thank you. So I would write it in this way. A is equal to minus 2y squared plus 16y. So I hope that you are not confused. Let me just finish this one, and if you have questions. If you work with mathematical functions, usually you have x in place of y. But that is just a matter of naming. Yes, now Gustav?
I didn't quite get what do you get negative 2y?
I multiply that here. Okay, and then I put minus 2y squared first, because a standard way of writing is writing the quadratic term first and then the middle term. That's it. Okay, now we want to maximize that. So what should I do? I need to complete a square, but this is one of those problems that I need to be careful here. So the first step is to divide by minus 2. Then this becomes equal to y squared. This becomes minus 8y. Which number I need to add here? Everyone, hopefully, that's very good that most of you actually, I think, know about this. What should I add? 16. 16, thank you. Divided by 2 squared. So I add 16, but I have to subtract 16 to get rid of that, what I am adding. And then you immediately see that I have a divided by minus 2 is equal. This one is y minus 4 to the power of 2 plus 16. So this is greater than or equal to 16. Agree? I made a mistake. This is a negative sign. Sorry. Because this one and this one and this one are collected, so minus 16 is left, and so this is not 16, this is minus 16. Okay, but then I hope that you remember what to do. A divided by minus 2 is greater than or equal to minus 16. You multiply both sides by negative 2. You need to remember to flip the sign. So it becomes A is less than or equal to 32. Yes? But usually, the maximum area is not important for you when you want to, for example, engineer in this fence. You want to see how to do it to reach to the maximum, yes? This tells you that don't try so hard, you cannot make it bigger than 32 meter squares. So then at most, your garden with 16 meters of fence, the area can be covered cannot be bigger than 32 square meters. Okay, so this is not part of the problem, but if you want, you can say, what is the maximum area? Area maximum is 32 square meters. So if your goal is to have if your goal from the beginning is to having a garden with the area 35 square meters, so it means that you need to pay money, because you cannot make that garden with this area with that length of fence. Okay, but this is not practical. Assume that you don't want to even pay 1 crown. So what should you do? How you want to achieve this? This is important. What is the answer? X should be what? X cannot be immediately read from here. What can be read? Y. So what is Y?
4.
Y has to be 4. Okay? But when Y is 4, what is X? 8. Yes? Because I put 4 here. 2 times 4 is 8. 16 minus 8 is 8. So it means that Y should be 4 meters and X should be 8 meters. So you are done. So you solved your problem. You have 16 meters of fence, and then if you make this one 4 meters and 8 meters, if you build your fence in this way, then you have covered the maximum possible area. If you want more than that area, you have to pay a little bit more money to buy some more fence. So this is a very nice problem, I think, because it's a practical problem. Yes? Any questions? Okay, I will stop here. Everything quadratic functions, more or less, is 4 full sessions. We were talking about quadratic polynomials. So there's one thing left from this chapter. I don't want to go very deep into it, and that is complex numbers. I will cover a little bit of that tomorrow and a little bit of Friday. So this chapter will be completely finalized by the end of this week, because on Wednesday you are not here. We have this Uzbek Samtal. Okay? Any questions? Thank you. Thank you for watching. Some of you are absent, yes?